Hi everyone, I am Abhishek Tiwari, a research scholar at Department of Computer Science and Engineering, IIT Patna. Today I'll be discussing our work towards multimodal medical dialogue generation. So the agenda of the talk would be, first I'll discuss about the what motivated us to work on this. Then I'll discuss about that key contribution, followed by I'll outline in detail what we proposed, and then I'll discuss about the experimental results we have obtained, and at the end I'll discuss the summary of the inference we make out of the findings and the results we have obtained. So, when we visit doctors, we often shows our medical condition using visuals because we think that we may not know the medical names to describe those visuals, right? So we often shows them to the doctors, and doctors identify what symptoms or sign it refers to, and they accordingly go for further symptom investigation and diagnosis. But traditional systems have this problem that they only consider the text. So this is what motivates us to make a multi-modal medical dialogue generation framework. So you can see in the figure that at the left hand side, the assistant which do have the only feature with the text fails here because it asks please describe your difficulties in text, but user don't know how to describe the session, the problem. For example, the mouth ulcer, he or she don't know the name of the symptom or sign, right? So but in right hand side you can see the proposed assistant we did here. It can also consider the images, right, and identify what sign it contains, and then the dialogue proceed further. So in this paper, we specifically investigate these three questions. First question is around investigating the importance of visual expression. What is the impact of considering the visuals along with the text? Whether it helps in symptom investigation and diagnosis. That was the first question. Second question was role of dialogue context in identifying an image, right? So in a dialogue, if an image pop up, should we also consider the dialogue context to identify that image? This was the second question we tried to investigate in this work. And the third one was what is the impact of external knowledge? Because when doctors do the symptom investigation diagnosis, they along with the medical practice, they also uses their learnings, right? So in order to put data set knowledge, we should also put the external world knowledge around those concepts so that it learns more effectively. So these three questions we try to verify in this research paper. So coming to the key contribution of this work, so first we didn't find a single empathy and sensibility aware multi-modal medical data set. So thus we created a data set which contain empathy containing utterances and responding to the patients. So we created a dataset called ESMDD, and we annotated each utterance with corresponding intent, sign, symptom, and severity level. We propose a model called Knowledge-Infused Multi-Modal Medical Dialogue Generation, KI-MMDG is in short, which contains NLU. So we first couple it with the NLU and dialogue generation module, because identifying the symptom and sign in the first phase of the utterances and then processing to generate a proper response that we perceived would help a model, and that is what I'll discuss how it helps and whether it helps or not, and then if it helps, how it helps. With the proposed model, we found state-of-the-art performance which outperforms the traditional uni model or other existing medical dialogue generations work, and we obtain efficacy over them. Also, the proposed discourse-aware image identifications, which consider dialogue context in along with the image to identify it, outperform the traditional systems. Now coming to the datasets that we have created. The first, you can see the overview of the existing datasets and its comparison with our created dataset ESMDG. So we didn't find a single dataset which contains all this feature like conversation, intent, symptom, multimodality, and severity. So that's what motivated us to create this data. It's called ESMDD. On the right hand side, you can see the statistics of the created dataset, and at the bottom we have shown the few visual symptoms those user often shows through images rather than explaining in text. and at the bottom right you can see the one dialogue samples how the patient and the doctor do the conversation, and at the end finally it prepares a report that what patient suffered out of it. So our system contains two parts. The first one is the NLU, which takes utterance as an input, identify what symptom and sign it contains. Along with the dialogue context, these extracted symptoms and sign are passed to dialogue generation module, which takes it as input and finally generates a proper response. So coming to the NLU, how it contains, you can see the patient utterance along with the images going as an input to this model. And there are two phases, two channels. If you see, the first one takes the text and the other one takes the images. The one text with the images identify what symptom it contains, right? So given the text only, it identify what symptoms it contains. For example, for this text, it's patient said, I'm also experiencing skin itching. So this is the sign, symptom, skin itching, so that it has identified. Whereas there is also an image, so that is going to the image channel, and which takes its pass it to one treated model BGC19, take the embedding out of it, and also it takes the context as an input, particularly the extracted symptoms which go into the clinical biobird, takes an embedding, and finally it merges these two embedding and pass it to two different neural networks. The first one gives what is the sign name contained in the image, and the second neural network gives what is the severity level, whether it's a moderate, mild or severe. Now coming to the dialogue generation framework, so this is a quite simple model. If you see, it is the NLU model is coupled with the GPT-2 module, and there we put our NLU part, which is intent and symptom identification, along with the discourse aware image identification, because for image identification we are not only considering the image but we are also considering context, and that is why we are calling it as a discourse aware image identification. So here if you see, it takes the utterances as an input along with the image, pass it to NLU, get the multi-modal belief state. What do you mean by the multi-modal belief state? It contains the sign and symptom that has been extracted, that is known as a multi-modal belief state. Along with that, this information is being passed to one knowledge method, which takes this utterance as input, identify what are the keywords out of it, and trigger concept net to get the relevant knowledge out of relevant to that, and that is being fed it to the GPT-2 model. If you see, so along with the this is the first part is the knowledge we are passing. The second part is the patient self-report, what patient has reported by themselves. And then we have the patient current response. This current response will go here, and then whatever the extracted, the semantic information we extracted, like the sign and symptom out of it, that is being fed here. And then investigation history means the previous utterances that also we are passing, and finally it is generating the doctor response, right, which is being again passed, is shown to the patient, and patient reply accordingly, and then the conversation goes on until the diagnosis. Now coming to the experimental setup, so here as I was talking about the discourse aware knowledge filtering, what does it means that given a dialogue, we cannot take all the medical knowledge. Given the context, whatever what we have already discussed, knowledge should be filtered out accordingly, right? Only the relevant part should be taken away, right? So if we are at the Tth utterance, only 1 to Tth minus 1 utterances would be passed as a context to the knowledge filtering method, which takes it as an input, identify the keywords out of them, and then trigger the concept and get the triplets relevant to them, right? And finally fed it to the model. So that is what the discourse aware knowledge selective filtering is doing. So here CT is the context, KGT plus 1 equals to means it was the Tth utterance, what would be the KGT, and then we are augmenting with the more utterance, with the more triplets that we are getting from the T plus 1th utterance. That is how it is working. And we are also feeding some most related potential diseases out of it. So given we are taking top 3 diseases considering the PSR, patient self-report, that we are feeding with that. We first train the NLE module, and then we train the dialogue generation module. The train split is mentioned here, and we have also the dataset and code put it on the GitHub, which anyone can access with the QR code. Now coming to the result part, this is the result of the discourse aware image identification. So we put the traditional model and then we experimented with the what is happening with the considering discourse as well, and we found that the model has outperformed the other existing models and identifying the image which also consider dialogue context as an input, right? So we also experimented with the different context windows, means the previous attention we found 3 works quite better. At the bottom one you can see first one at the top one is for the symptom identification and the bottom one is for severity identification. So these are the 2 things. Now coming to the dialogue generation module. So KI-MMDG is our framework and others are the existing frameworks. So we can see in all evaluation metric it has outperformed the existing method by a large margin, Blue, Ruse or Meteor. Similarly, we also did the application study to understand what are the importance of the different part. So we found KZ influence at some extent, VS means visual symptom influence at some extent, and when we are putting them together it is working quite better than them. So they both have the contribution, knowledge infusion as well as the visual symptom putting it there. Now coming to the key findings, what we have inferred from the result is that the dialogue context helps, whether it is the dialogue generation problem, whether it's image identification. If you're considering dialogue context, it identifies the image more appropriately. We also obtained one interesting finding is that given the knowledge, it narrows down the exploration space for the symptom, right? And the agent effectively identify do the proper symptom investigation and ultimately diagnose with the correct disease. While knowledge is definitely important, focusing on the relevant knowledge is also important. That is where we found that the method where we have knowledge distillation, it helps more than putting all knowledge together. Now coming to the analysis part, we compare with the different modules and to understand what contribution they have given, and we found that the model which have both the part BSI, visual symptom and severity part, as well as the knowledge, it is doing far better than alone one. So knowledge infusion not only helps in identifying the disease or the symptom correctly, it also helps them to identify the disease more appropriately, and indirectly it helps that whether the model should generate more empathetic response given the situation. Now coming to, there is one problem also with our system that we identify. It is the symptom agnostic symptom investigation. What do you mean by that? If in the goal data it contains do you have a fever, it should ask the fever at the same utterances and same time stamp. Otherwise, it will be a mismatch with the goal and it will be penalized. Now coming to the conclusion, in this work we propose knowledge-infused multi-modal medical dialogue generation framework. We also introduce discourse-aware image identification, which identify the image, sign as well as severity. And we found that clubbing this knowledge infusion and NLU with the GPT-2 model helped and did the more appropriate response generation than the traditional system. Thank you so much for hearing. So these and you can find out the resource at the given QR code and connect me at the LinkedIn with this QR code. Thank you so much.